Merci beaucoup. Bonjour. Je vais passer en anglais, mais avant quelques mots, parce que finalement, vous avez dit une bonne partie des choses qu'on avait prévues en intro, beaucoup mieux que ce que je vais le faire. Et merci aussi pour le soutien pour les PEPR, parce que si vous partez, je n'aurai pas l'occasion de vous le dire directement. Donc, if I will switch to English, and we have this first slide just to explain a little bit what are these objects, these PEPR, because for me, in the last 2 years, this is probably the word I have used the most, PEPR, but for many people, maybe in the audience, it's not the case. So it has been said just before, this is this program from the French government in order to structure some community, to support some scientific fields that are linked or likely linked or to be linked to transformation. And Bruno Bonnel talk about transformation, societal transformation, economical transformation, environmental transformation. And in total, this program was about 3 billion euros for fundamental research. I mean, low TRL was targeted first. And it was already introduced. There are 2 types of these programs. Some of them are acceleration programs, PEPR, to support transformation that have been identified by the government, electronics, quantum, battery, AI, and so on. And some other PEPR, exploratory, like the pepr-spin, to support some transformation that just begin to emerge. And this is exactly what we had in mind with spintronics, that was considered as upstream compared to electronic or microelectronic, for example. So there are in total 22 exploratory programs, 1 billion of funding during 10 years. And you see, we have also, one of the objectives that we had at the beginning of this program was to create connections, both with this acceleration program, so in order to integrate our fundamental research in strategies at the national level, strategy in electronics, in quantum, in AI, but also to promote connections with other exploratory PEPR, for example, light matter interaction of this Diadem program on advanced materials. And then, more recently, there have been the creation of these agencies that are in charge of coordinating the effort on particular topics, and we are directly involved in ASIC, and we will have some discussion about this agency during the roundtable on numerical compounds, and this is where the action of our PEPR is integrated or start to be integrated in the discussion about this strategy. So it was mentioned that one of the ideas and one of the objectives of this PEPR is to try to provide solutions to challenges, and the let's say energy cost of digital world of AI in particular is one of these main challenges that we have to face. Here are a few numbers, striking numbers of the cost, and that probably not sustainable on the long term of AI for the use of AI or the training of AI. Also for the automotive, for example, the cost to have autonomous vehicle is probably not sustainable with the existing solutions. And this is where we believe our fundamental research in spintronics might bring some solutions, some answer to this critical issue that is the cost, the energetic cost of the digital component. There are other challenges, and we will have a focus, for example, today on materials, the criticality of the materials, to find ideas, to find solutions in order to replace some of the critical materials. This is one important challenge. And at last but not least, I think everybody in the room is now aware of this question of sovereignty, technological sovereignty of France, of Europe. And we believe that in order to answer, at least partially, some of these challenges, there is a need to disruptive science, disruptive technology, and we believe spintronics can be one of these very promising solutions. So what is spintronics? Yesterday we had the scientific day, and we talked a bit more in detail about that, but I will summarize. In fact, in spintronic, we use the fact that electrons, and not only have a charge, they have also a spin angular momentum. And the idea is to use this additional degree of freedom in order to create new, to generate new effect, new physics, new functionality, and new devices. And the basic idea is to combine magnetism. A spin angular momentum can be seen as a small magnet on the electrons, to combine the advantages of magnetism and of electronics, and to generate some solution with very low energy cost and in ultra fast or ultra short time scales. In spintronics, and from the very beginning, about 30 years ago, the success and the emergence of this field of research came from engineering of material property at the atomic scale, and you see here this kind of stacking of these different thin films of materials, the drawing, and here you have the actual picture of this basic structure of spintronics, this what is called magnetic tunnel junction, and also the fact that it has been very rapidly integrated or co-integrated in solutions to generate spintronic devices. I mentioned already that this field of research was born in the end of the 80s with a discovery by Albert Fert in France and Peter Grudberg in Germany of the giant magnetic resistance effect. You have here on the left the first experimental curve of this giant magnetic resistance effect, and I think Frédéric Petrov is in the room, and he was the master student measuring this curve, and this is really the convergence of some advances in material research and fundamental physics in the transport property that has generated this discovery of giant magnetic resistance. And very rapidly, there have been very often some back and forth motion between fundamental discovery in spintronic in the last 30 years and large-scale consumer application in data storage, in sensors, or more recently in memories. And the spirit of the pepr-spin was really to leverage on this dynamic of this field of research, on the dynamic and the creativity of the French community, all these new branches of the field of spintronic, hopefully to continue this virtuous cycle between fundamental research and some potential applications. And we are not the only one that would be believing that spintronics can be a very interesting solution. Spintronics has been identified in Asia, in Japan in particular, but also in Korea, in China, as a very promising emerging technology. And today there are some very large scale or very strong investment by the main actor in microelectronics. Some of them are cited here. And the idea is also, Bruno Bonnel mentioned the importance of having a community, structuring a community. And this community of spintronics in France was existing. We have in the pepr-spin all the French researcher and engineer working on spintronics are part of this program. We have 15 universities, about 50 laboratories. And there are also, we will leverage on this culture of innovation that is existing in this field of research. At last but not least, these actions was also very done in parallel with what is done at the European level. There is this network called the Spintronic Factory, where the French actors are the pilot of this activity to promote fundamental research, but also transformation, exploitation, and transfer technology in spintronics. So the program, the implementation of the program, we choose at the beginning 5 topics in the spirit of the pepr exploratory that are a topic we identify as very promising, emerging, where the colleagues in the French community were at the forefront of this research. So we have 5 projects, moonshot projects, and we want to kick them very far if possible. Beyond CMOS with chiral textures, spintronic terahertz technologies, some spin wave used for advanced signal processing, radio frequency property coming from the precision of magnetization for communication solutions, and next generation of magnetic sensors using some of the most recent advances in this field of research. And all of them, even temporarily, we try to make them in parallel with the national strategy, in the sense that the timeline of this project was supposed to end at the same time that some of the acceleration programs. So the idea was really to try to bring as much new ingredient as possible in this national strategy. And this is what is shown here. We started in November 23. We started this 5 moonshot project I mentioned just before. At the same, and you see they will end probably in 2028 concomitantly with some of the acceleration programs. So this is exactly in the spirit of agency also to be connected temporarily. We have in green the national platform or infrastructures in terms of advanced materials, advanced characterization tool, and the support from theory and numerical simulation. And the idea is to develop this platform in order to also open some opportunity to the academic community, but also to use some of the industrial to have access to these platforms. And we have also 2 series of open calls with new projects, new ideas, new solutions, resourcing of the science in order to bring things that maybe might make a big difference in the future. The bottom part is to indicate that we have a project more targeting this exploitation of the results, a project together with a top-link innovation that is meant to support more specifically the moonshot project in this action, in this effort, in order to transfer this technology, transfer the result, turn this research excellence of these programs into potential use or used by the industrial colleagues. Very rapidly on this national platform or infrastructure, we have one on the materials. You see that is many laboratories and equipment in France have been supported by this action, by SpinMat. And the idea is to open this tool to propose solutions to the community of academic researchers, but also to open this equipment to the use for industrials. And we are in the process to make this connection easier for the industrial actors. Second program is for advanced characterization to really offer and promote advanced characterization facility with metrological grade quality. And same as SpinMat is for the academic community, but also to open these tools as much as possible to industrial actors. And the last one is on theory and numerical simulation. There is also, for example, for developing some new numerical methods. We have been talking a lot about AI. I mean, how to use AI, for example, in our research is also part of this program. And then I will conclude my part on this timeline. I mean, this is just to show that we started in November 2023. We are today at about the half of this program. A very important event for us is the midterm evaluation that we will have in the last part of 2026. I think we can be confident that we have done already some great advances and great results. And just to show that we had yesterday the scientific day. Before we had several of these events. So this is the idea of structuring this community. And in addition to this activity that is more targeting the scientific part of the pepr exploratory, we already had a first industrial day, very short after the beginning of the program, in order to try to bridge the gap between what we can propose as a solution and the needs maybe from the industrial actors that are connected to this field of research. And tomorrow we'll have the second industrial day. Today we have the second industrial day. Thank you.
Thank you very much, Vincent. So I'm just coming back to more focus on the industrial part. So we had this first industrial day in November 28th. So that industrial day, thank you very much for your presence. So that industrial day covered already several aspects of how we try to link with for example, pole de compétitivité, how we address several applications, namely addressing some roadmaps, going into the memory part, link with ongoing actions on pilot lines, but also trying to look toward some dual military application. In terms of industrial exploitation and partnerships of the PEPR, so Vincent mentioned that we tried to innovate as exploratory program, which do not have as initial target. You have the belle science, nice science that have to be done, but also to transfer to acceleration strategies, some of the developments. But from the beginning, we wanted to give a momentum with a dedicated contract in which we wanted to put in place an exploitation plan for the moonshot project that we mentioned, the Kirex, Toast, Swing, Spincom, and Adage. With the idea is to provide advices to them for their industrial exploitation plan. Maybe not all of the nice ideas are meant to go to industry, but there is also nice science, so this is acceptable. Also to assess current and future industrial needs in relation with the research directions of the pepr-spin, to set up and coordinate an industrial advisory board, and to assess some targeted markets, identification of third-party operators. So that industrial board, which is composed with some big groups, some of them European, like Global Foundries or in Germany, but all others coming from different fields like Dassault, aviation, Thales, Menta, HProbe, Alice et Bob, but also linked with Minalogic, Pole de Compétitivité, and an investment fund, Supernova Invest. The idea was to strengthen interaction with industrial stakeholders, and the example of what was done, and this is just a working in progress example, so we tried project by project and that's an example from the Adage project on magnetic sensors, to address what are the technological bricks we want to develop, what are the main challenges, what are the applicative domains for them, what is the added value for that, and what's the timeline which is projected to bring, I mean, a change in the sense of influence of the electronic market. So that's an example that, of course, today we will have 3 different focus we want to work on, but all the 5 projects were organized in that way, and the industrial board that will take place tomorrow is to go into detail and to see how these projections can fit with the roadmaps of the industrial partners. Another important aspect is how to train the young researchers in the sense of protection and valorization of results. So there is an ongoing actions with our institutions, but also with the local PUI, in the sense of informing together. For example, today there is also a dedicated stand in which people can discuss with colleagues from CEA and CNRS Innovation that are helping us. And for example, on June 9, we'll have a dedicated webinar on this aspect in maturation, valorization of research results. And for example, this is a QR code with a pre-webinar survey in which you can look on the various questions or propose some suggestions on how to work together. What is important also, Vincent mentioned that we are not alone, we are linked, so thanks to Isabelle as coordinator of PPR Electronic to participate both to the Scientific and Industrial Day, to other PPR. But also the momentum of the PPR is important to contribute to the strategic analysis on different aspects. So there was this action on advanced materials in microelectronics, participate to different working groups on that. We tried to reinforce links with DGE, so also thanks for being present today and participate to the next roundtable in order to show what's the spintronic and how to link it better with an existing industrial framework in which potentially some of the key actors are not dealing necessarily with spintronics. And we try to show that we have some assets that can be exploited. And of course, the emergence of the agencies recently is also an important and gave us a kind of real discussion point with the agency, but with the other PPRs, and that's an important asset to exploit all our discoveries. This is not only linked to France, and we mentioned that, namely in microelectronics, this has to be linked with the European strategy, and the fact that, I will mention, we have an ongoing project on the framework of geochips, in the framework of CHIP Act, is that our actions did not started with a PPR. So it's something that started a long time ago with some roadmaps that we put in place in order to bring also more industrials in the board of European Magnetism Association, to try to have a task force in the framework of IEEE magnetics on magnetic and chips, embed a spintronic solution within the European geochips, as I mentioned, but also try to see working on the next European framework program, FP10, with the agency, with IPIC, in order to bring spintronics into the future call. So an example which the PPR is proud is also this spin chip project, which PPR was used as a lever in order to go to Europe and to prepare the next steps. Of course, linked to our initiative in Spintronic Factory, we were successful in proposing this spin chip project, in which we want to deploy the existing technological brick, which is the magnetic tunnel junction, to different types of applications, which are going to different type of applications like memories, artificial intelligence, sensing, and the project was selected by the European Union in November 25, coordinated by Thales, Paolo Bortolotti, with 32 partners from 10 different countries. An overall funding, which is 23 million for 42 months, but also an example which is not necessarily known for the community, which is more fundamental upstream, to combine different fundings coming from Europe, but also from national fundings, from BPI, or what PPR spin is bringing to that in order to finalize the budget. So all this is a nice achievement for us and important in order to move to higher TRL level, and the kickoff meeting will take place in beginning of June in Palaiseau. And I will finish and anticipating a bit the discussion in the round table. So we are happy to participate in December 24 in a meeting organized by SGP on how to anticipate the PPR technology transfer, namely for exploratory programs. So we are happy to participate to that day. So and happy to discuss during a day in which in a working group in which different colleagues from different institutions, some of them also present here, participated. And we were able actually to, and we have to see after 18 months if all the ideas that we discussed at that time are still active, but definitely the roundtable afterwards will say that. There are aspects that, of course, we have to reinforce in the national strategy, how to reinforce the technological transfer, but also how to train the new generations. And this is just a reminder of we are following the actions, some of the ideas that we had, so we'll compare them with the outcome of the roundtable. But namely, on the national strategy on microelectronics, we came up with some need of support to the jointly built global strategy in between the different agencies to link between the upstream PPR and the acceleration PPR, how to integrate technology transfer and impact considerations into programs and harmonize with various valorization structures, how to contribute to the European international strategy, so I mentioned some of outcomes, how to establish a complete value chain and ecosystem, going from materials design, packaging, how to sustain a long-term funding from the fundamental research. And we are happy that Bruno Bonnel was somehow aligned with that, with the need of adding some funds for the fundamental research. In terms of technology transfer, we mentioned that there is a need to establish an industrial board, so we did it, to qualify specific markets. So in that sense, the different aspects we are discussing today with the different moonshot projects are important. We mentioned that there is a need of identifying a third-party operator for the exploitation plan, so we moved a bit into that direction. Intellectual properties, analyze IP policy based on transfer impact strategy, transfer challenge to implement for the exploratory electronics side. And on the training part, invest in the attractiveness in science and physics. So yesterday we had Sylvie Roteo, who participated as head of Universe Science, with the reopening of Palais de la Découverte with a dedicated topic on spintronics. So that's also important for the attractiveness of the community in terms of science outreach and public engagement, and of course helping young people to be skilled and trained for the future in electronics. And just before moving to the roundtable,
the digital revolution is transforming our lives, but comes at a major energy and environmental cost. By 2030, the digital sector could account for roughly 10% of global electricity consumption. In response to this challenge, the SPIN research program, funded by France 2030, co-led by CNRS and CEA, invest 38 million euros over 8 years to rethink our digital technologies from the ground up. Its mission, to develop electronic solutions that are faster, more powerful, and above all, far more energy efficient. At the heart of this program lies a rapidly expanding field of physics: spintronics. Spintronics harnesses a quantum property of electrons, their spin, and paves the way for more energy-efficient electronics. This field builds on the groundbreaking discoveries of Albert Fert and Peter Grunberg, 2007 Nobel Prize laureates in physics. This program brings together leading research institutions and fosters new industrial partnerships to accelerate the adoption of spintronics across diverse fields: communications, computing, artificial intelligence, security, and healthcare. It also establishes a national network of technological platforms to develop new materials and devices, assess their performance, and create predictive models at various scales. SPIN includes a training initiative to prepare the workforce of tomorrow and introduces spintronics to the public through scientific outreach. More than just a research field, spintronics enables electronics technology capable of meeting the energy challenges of the digital future.
So that